So I have two SAM driver boards in the shop, and both of them have switch matrix issues. These are the switch drives, as Stern calls it, but they're switch columns. And this array of 8 transistors, 1, 2, 3, 4, 5, 6, 7, 8, implements the switch drive. I haven't tested this one yet, but I'm ready to test the one that's right below it. So this is the same transistors with the board flipped over. So I'm going to show you how I test transistors, and we can identify if any of these have failed. So I have my meter set to diode check. It's a diode check symbol. This happens to be a Fluke 179. Any quality meter with a diode check is useful for this. Now, the first problem that I always have is I know to put one probe in the center leg and then the other probe on the flanking legs, but I never remember which one is which, and it makes a difference whether it's a PNP or an NPN transistor. So I just try it. You know, somebody asked me, did I get that right? And this time I did, but I would have guessed first black in the center, and those readings just don't make any sense. So we're going to go with red in the center. I get 0.7 on one side and 0.69 on the other side, and that is a good transistor. Moving on to the next one, another good transistor, another good transistor. This is a shorted transistor, so that I don't lose track of which one that was, I'll put that little dot there. We'll move up the line to check the rest of them. I believe these are 2N3904s, but again, I'd have to check. Jesus. Okay, so the rest of those transistors are good. Let's see what that transistor is. Yeah, it is a 3904. So I'm going to change that transistor out, and then we'll go test this board on the bench. So one thing I'll point out on this board before I install the new transistor is that the traces on this board are very, very fine. There's a trace leading southwest from this through hole to one of these resistor capacitor pairs, and then there's a trace leading from the center hole to this surface mount component. The SAM board is a 3-layer board, meaning that there is a copper foil on the top, on the back, and then there's one in the center that you can't get to. Usually that's a ground plane, but sometimes it's not. The last White Star board, the White Star modified board, did the same thing. And here is the other SAM board, and I'm going to test it in the same way. And you see I do forget which probe goes where. So this is a good transistor. Let me get my hands the right way. This is a good transistor. And this fourth transistor up, same one that failed on the other board. And see, it's failed. It's failed in a different way. This leg, these two legs are not shorted, but the reading is 1.8 volts. And of course, that is way out of range for the characteristic voltage drop across a silicon diode. And this leg is shorted. Every time you measure across a silicon diode, the reading should be between about, well, it should be about there. You know, we say between 0.5 and 0.7, sometimes 0.4 and 0.7, which would disqualify this particular one, but I know that this one's good. So those 0.4 to 0.7 rules of thumb are not necessarily 100% accurate. And let's boot and test the second of the two SAM MPUs. Interesting, both of them have Indiana Jones ROMs in them. I did rejigger my WPC test switch dongle. So let's go through the same thing on this board. I'm just touching the pins together. A long time ago, people used to think you needed a diode when you were doing this, but you do not, because a diode is there merely for switch matrix switch isolation. And we aren't isolating anything in this test. So this one's good to go Also, thanks so much for sending them. Indiana Jones SAM MPU had a switch matrix problem, and the second 2N3904 from the left was blown. I am testing these switches sort of the brute force method. I have a connector connected to row 2, and I'm going to rake the inputs starting here and show you that all the columns are working for row 2, which was problematic before. I really need to update my switch tester for SAM boards. Anyway, this one's working great. On to the next one.